thank you very much for your talk, Tong-Yi. We are having a discussion now, essentially, and there are, Ralph, will you read the Q&A questions?
Yes, so we have first question by Luca Giringelli, which is a technical question on how the combination of features is made. First, product of powers, and then operators, like exponential functions, log, sine. Did you understand my question?
Can you hear me?
Yes, we can.
Yeah, okay. So there is a few questions. Okay, I get that.
Yes.
The first one is
maybe
how
Luca can, maybe Luca can actually ask the question first, if that's possible.
Yeah. One is about the technical question on how the combination of features is made. First, the product of power, and then operators like exponential, log, sine. I would rather ask in person, if possible.
So
it's
yeah,
possible.
So, Luca can ask.
Can you hear me?
Yes.
Yeah, sorry, that was just a question to the organizer that I like to ask the question. It was not a complete question. So I'm curious that you showed that you first make these products of features elevated to some powers, and then you apply operators like logarithm, exponential, and so on. And I was wondering if you have as a constraint that the argument, so when you form the block that is a product of powers, it has to be a-dimensional, so without a dimension, because when you apply exponential, logarithm, or trigonometric function, you expect that the argument of the function is without a dimension. So I was wondering if you construct these blocks such that they have to be without a dimension, or you allow anything to enter an exponential or something like that.
Very good question. So actually, say when we further do the dimensionless, okay, like all the variable become dimensionless. But however, keep that in mind. We also allow that we call constant. We put this in number 1. The constant could also hold some dimension. Then they make the total formula, okay, or each term becomes dimensionless. That means in each of these terms, or I call future blocks, they could have some constant out there. When they have this constant, because the constant holds some physical dimension, then they make the total physical dimension balanced. Luca, whether I answer your question or not.
Yeah, precisely. That was what I wanted to know. Thank you.
Yeah.
All right. So we have another question in the Q&A, which is it possible to access the Materials Genome database from Europe?
So we are trying, because when I build up this is the database, actually Professor Chen is here. He is really running our database. Okay. The first thing we have tried to encourage all the people, they can share this data with us, especially for experimental data. And also now currently we are also working with the industry for the companies manufacture data. We have to ask and encourage them. For manufactured data, we have to sign some agreement with them because they have some financial, for the industry that have some rule, we have to follow that. As I mentioned here, who provided the data, who will hold this data right? Okay, that is who will determine when and to at how large scale, how to some people they can share that data. Because that is a very, very important, especially when you are working with the industry people. Okay, the industry people, they want to use our materials informatics, use also MGA approach to speed up, to facilitate their manufacture. So we have to keep out, okay, their own interest. Okay, that we have to keep that in mind. We cannot just ask them, you say, to provide the data and do not protect them, protect their interest. We have to do that. We have to consider that. For academic people, it's relatively simple. Say, especially to that is a computation data. We can see in our database, we try to collect all those data, not just computation data, and also experiment data. And now we are working with the industry to handle with the industry, the companies is manufacturing data. So we have to fully say, by any means, to consider their own interest, to encourage them to share their data with us.
Okay, thank you. There's another question by Joshua Salazar. Maybe this can also be asked live.
The last question is a very much a challenge.
We have one live question.
How do you make sure you end up with a formula with a real physical meaning? That is very much a challenge. So that is why in my presentation on purpose, we get a formula about creep data. So for metals and alloys, it's a creep. You know how high temperatures is the alloy. That's a creep. It's also very, very important issue. We get some formula. The formula, we have not really understand the real physical meaning. Okay, that is very much a challenge. We still want to try to get what is one from our use our domain knowledge. We get one formula. Okay? That's a formula. They also very much is general, but the data currently we use is not so large. Okay, you know, it's especially for experiment data. You get a very big, large data is very, very difficult. And also, as I mentioned, that the data always have some noise. So we still make a comparison. We still try to dig out what's the real physical meaning. So that's why I emphasize very much. We have to use our domain knowledge. Okay, we have to use our domain knowledge. Without the domain knowledge, it is very difficult to get a real physical meaning formula.
Okay, thank you very much. This the answer to that question was asked from Olivia Lenz. So now we have the live question from Joshua Salazar.
Okay, another question is I'm new to machine learning method. What are the conditions?
Tong-Yi?
Yeah.
Sorry, Joshua can ask his question in person if you let him speak. Joshua?
So only this is okay. Let's read that. Okay.
So I read the question. What is the condition for choosing such functions? And to which components multiply them? Is it arbitrary?
Okay. I understand this. Okay. When we ask always a colleague to do the machine learning, I usually ask my colleague to select not only one machine learning algorithm and use many machine learning algorithm, because you don't know what is really behind the inside your data. We cannot say at the moment which algorithm is the best to your data. You have to make a comparison. Actually, I have other examples. I did not show you. Okay, we have demonstrate for different data. We can use a different algorithm. It's not always deeper learning is the best one. Okay, you keep that in mind. Sometimes very simple machine learning algorithm maybe it's fit your data perfect.
Okay.
So that is depend on, say, by your data, your natures of your data. Without this really analyze that data, I cannot say too much. Only I can ask you to try more machine learning algorithms.
I take the freedom to ask the last question. So a physical dependence usually has the functional form, which you described, but it also has some material-specific parameters. And these parameters can have very non-trivial dependencies on other parameters. So what is your strategy to disentangle functional dependence from contributions from material-specific parameters in a formula?
I just mentioned that we are seriously working on that with some crypto data. Okay, so why we are working on those crypto data? Because my former student in Hong Kong, we have published some paper, and also that I use my domain knowledge. I actually have an expert a formula. That formula is also based on data. Okay, it's based on data, but with my domain knowledge. Each term in that formula has real physical meaning. We know what's going on, what's that is for materials design, okay, what we can do. And now we use this the algorithm we just developed. We get from fittings point of view, okay, from data, just purely talk about data. Their fitting, the accuracy get much better. Not too much, but get better. The challenge is we really don't know what is the physical meaning for that. We get that is a constant. Keep that in mind. Constant sometimes is very important. I give you one of these example. For example, we all know the ideal gas. We know this pressure times is volume equal gas constant times temperature. This is the number of gas constant. That is a constant, but they do have a physical dimension. Okay, keep that in mind. And that is you found that constant, you will make a big contribution to science and also to engineering.
All right, thank you very much. So Tong-Yi, thanks for the discussion.